So this video is going to talk about percent yield and how to calculate it in a stoichiometry practice problem. So percent yield is a way for chemists to talk about how did it go, okay? We can talk in percentages. Hey, I got an 85% on that test, so I got a 75% on that test. It's an easy way for people to communicate because everybody knows what a 15% means versus a 90%, what that actually is. So percent yield is useful for that. For this calculation, we're going to have to use something called a limiting reagent, or another way we could call it is the limiting reactant. Okay, both are used interchangeably in the world of chemistry. So limiting reactant, limiting reagent is used to determine how much product can be produced. So this is going to be what you call your theoretical yield. So if everything went perfectly, how much could you have made? So the formula you use for percent yield is actual yield over theoretical yield times 100. And again, we just do things in percentages because we all know what that number means. When we talk in moles, that's something different. Most people don't know what that means, or grams or other things. So percentages is a very easy way to compute that. So actual yield is the amount of product produced in the experiment. So this is, if you did an experiment, you have something at the end of it and you mass it, that is what you call your actual yield. In the case of the problems you're going to see in class, they're going to be given in the problem. So you're going to say the actual yield was 2.6 grams of this product. So it's usually going to be given in the problem some way, somehow, especially since we're not doing it in a lab setting. The theoretical yield then is the amount of product that should have been produced. So this is where we're going to use the limiting reactant, limiting reagent here to calculate this. So this is going to be the calculation we use to do this type of problem. So in most cases, you're going to be calculating the theoretical yield, and I will show you an example. This is going to be given, and you're going to be asked to calculate the percent yield. So those are going to be, again, the steps that you go through. So I'm going to do this practice problem for you, so you could see how this all plays out. So here is my balanced chemical equation. So 2 aluminum plus 3 copper 2 sulfate produces aluminum sulfate and 3 coppers. So I have 1.87 grams of aluminum to start the reaction. So the copper sulfate, let's say, is in what we call excess. So this is my excess. This is my limiting reagent or limiting reactant. In the experiment, I produce, so again, the product that we're looking at in this case is copper. I could look at the aluminum sulfate, but that's not what the question is asking. But I produced 4.65 grams of copper. So this is my actual yield. Okay, so I want to find the percent yield. I want to find the percent yield. So for these types of problems, the first thing I must calculate is the theoretical yield, okay? So what these are is essentially a gram to gram problem. That's all this is. So I'm repurposing what we've been doing all along from unit 2 and now into unit 3. I'm just going to convert the grams of aluminum, convert it to moles. I'm going to take the balanced chemical equation. Oh, I have a 2 in front of the aluminum. I have a 3 in front of the copper. I have a 2 to 3 relationship. And then I'm going to go to grams of copper. So if everything went perfectly, your theoretical yield is going to produce a certain amount. So the first step I'm going to do is grams to moles of the aluminum. So I'm going to take the 1.87 grams and figure out how many moles that is. So again, aluminum is nice because you just got to look it up off the periodic table. So 27 grams for every 1 mole. So again, you cross multiply, you get 0.0692 moles of aluminum. Okay, so that's the first step in pretty much most of the calculations that we do. The next step is a mole to mole problem. So I'm going from moles of aluminum to moles of copper because that is what's given in the problem, and that's what I want to get to. Okay, so I'm going to take this number of 0.0692 moles of aluminum, and I'm going to figure out how many moles of copper that is. So I have to use, again, in most cases, you're going to be using a balanced chemical equation. So I have a 2 in front of the aluminum and a 3 in front of the copper. So I put a 3 moles in front of the copper and 2 moles in front of the aluminum. And again, it doesn't matter how you set up your proportions as long as it's aluminum, aluminum, copper, copper. So this I get 0.104 moles of the copper. So the last step is to go from moles of copper to grams of copper. So this, again, I'm going to put grams on top. That's just how I do these problems. 0.104 moles of the copper. And then I look up very nicely on the periodic table. I look up copper. It's about 63.5 grams for every 1 mole. So then I cross multiply and I get X is 6.60, again, 3 sig figs grams of copper. So this is my theoretical yield. So calculation-wise, if I started with 1.87 grams, I should get 6.60 grams of copper from the balanced chemical equation, okay? So I'm using my gram to gram stoichiometry setup that we've been doing for a purpose, okay, to find my theoretical yield. So to find your percent yield, that's easy, okay? I was given the actual yield. So when I did the experiment, I massed out at the very end 4.65 grams of copper. So 4.65 grams of copper. And my theoretical yield, I have to always calculate from the balanced chemical equation and what's given in the problem. So this is 6.60 grams. And then I multiply by 100 because we all know what percentages are. So it's about 70.5% as my percent yield. And maybe that's good for this experiment. Maybe there's a lot of problems with this production of the copper, whatever reason that might be. So this might be an okay number, or it might be a horrible number, because again, the goal we want for percent yield is 100%. That's the goal. Again, like getting 100% on a test, same kind of idea. So when we're looking at percent yield, you're going to have a theoretical yield you're probably going to have to calculate, and you're going to have an actual yield given in the problem.